Hello and welcome to the latest instalment following the restoration of our 2-foot gauge Fowler narrow gauge locomotive. These are really interesting. This is the original job spec sheets for our locomotive from the Fowler factory. You can see on the right hand side the batch number 16339 to 41, which is the batch of 5 locos for Tully Sugar Mill. It shows the order placed by the Agent General for Queensland on June the 4th, 1924, and they're full of fascinating details. Here you can see it says olive green lined to match, one of these locos to be prepared for photography, which of course we've seen with the works photograph of Tully number 2. They're an amazing find, kindly sent to us by Jonathan Palterman, who, when the Fowler factory was being demolished, went along with a friend in a van and loaded it up with all the stuff that would have been lost to history had they not made that effort. The numbers that you can see on the right-hand side are the specific drawing numbers that we used on our locomotives, so we know exactly how each part was made. And the handwritten notes are from the actual workshop floor, showing what they did differently and why they did things on our individual loco. So an invaluable part of its history, and we're really grateful to have received it. So moving on to the engine, here's Jenny cleaning up the wheel sets, ready to go off to CMS Setcore, which is essentially Bagley's Engineering, as it's now called, and where they've got much bigger lathes and much bigger kit than us to be able to deal with them. The tyres were pressed off with a massive hydraulic ram to get the tyres off the wheels for machining, as you can see here. They pressed off the fly cranks too. It took 120 tonnes to push these fly cranks off the end of our axle, so quite a force that we couldn't have done ourselves. You can see it's balanced here on the lathe, and you can see the crank pin itself running a little bit eccentrically. That's just because of the wear on the actual pin. It's actually centralised properly, and we're machining it down, getting them all ready to be back on the engine. We'll send them back down to Setcorp, who will press them back on the axles for us. We've got quite a lot of machine tools at the steam workshop, but some things are just a little bit too big for us to comfortably handle. Here's the fly cranks all ready to go back down to be pressed back on the axles again. Interestingly, they're marked up with 39. 39 is 16339, which is Tully number 2, not Tully number 5. So they're not off our locomotive, they're off one of the others from the batch. The longer pins are obviously the driving crank axle, and the shorter ones are the coupled wheels, the front set. The trailing pony truck here on the big lathe is clearly running very out of true. It's got a bent axle, as you can see. We've decided to treat that by skimming everything down to make everything square, and thus the only part of the wheel set that won't be true is the actual cast spokes. We don't think that'll have a significant impact on anything being out of balance. Moving on now to the axle boxes in which the axle that you've just seen runs. They're 3-part axle boxes. You can see the bottom part there that holds the oil, the top part that retains the structure, and then there's a bronze shell that goes over the top that the axle actually bears upon. In the real world they look like this. You can see Jenny cleaning the years of muck off the bottom part that goes on to hold the oil. The main part is there with the slippers on the side for the horn guides, which we'll come to later, and there's the bronze shell. We then cleaned all the muck off so that we could see the wood for the trees, so that we can make assessments on what we need to repair. The oil retainer at the bottom is like this. It has a space for a felt that holds the bulk of the oil, and it has another felt that sits up in an arch and touches the underside of the axle, thus keeping oil smeared on the axle as it rotates in there. The bronze then sits over the top, and the axle bears upon that. And you can see in the top there are 2 holes which, when the axle box sits over the top, allow oil to filter through from the reservoirs in the top through into the slot and onto the axle itself to make sure it's continually lubricated. Now, at some point the axle boxes themselves have got so worn at Tully Sugar Mill in the horn guides that they've needed extra pieces of metal put in there to build them out again. That's what you can see there. They're all worn and pitted as well, so we're removing them. We're having to drill out the countersunk screws that are holding them in, because they were just so rusted in that we couldn't shift them in any other way. So we're drilling through the screws in this little bit of the film, and then we're going to prise and pull that part of metal off so that we can make brand new ones in, which will be oversized, and then we can machine those pieces of metal back down to fit exactly where we want them to in the new horn guides. You can see also here the surface of the axle box is incredibly pitted. It's a steel box, but it's all rusted away. We don't want to use new boxes, we wanted to use the original parts. So we've filled all of that rust and deterioration with weld. We've welded it up so it's an oversized surface, and then here we're milling it back to the correct size with the milling machine. So we're milling off that weld to get it back to a fresh, perfect surface to the drawings of what it should actually be in the first place and what it would have been before the rust and the wear. Moving on to the frames, this is an interesting part of the project. That's the front buffer beam. And the line that I'm tracing with my finger now shows where we've found a big kink in the frames. On the right hand side, this is the plan view looking down from the top, and on the left hand side. The loco's obviously had a very heavy front end impact at some point in its life, and it's really bent the frames. You can see that line that I traced on the drawing being traced with my finger there with the black line down it. And when we go over and look down from the top, once I move the glove, you'll be able to see that it's very badly kinked over to the right hand side. We obviously need them to be straight. Same story on the left hand side here, and you can see that there's quite a thick wedge in behind the front buffer beam and the angles of where it's all bent. We needed to chop that section out along those lines and weld in, as you see here, a brand new section of plate at the front end. We did consider heating it up and putting long arms on it to try and bend it square, but ultimately we decided that that would be quite a difficult thing to actually practically achieve in the real world, and this was the most sensible solution. Looking from the top, you can see it's now much squarer, although we've still some work to do there on straightening the buffer beam itself and the angles. This is the frames now returning back from the welders and the fabricators and the shop blasters, ultimately back to the workshop, where we can really start to get them set up and sort everything ready for the wheel sets and axle boxes to go back in again. They look a bit scruffy because of all the welding work and repair work that's been done to them. The boiler, then now empty of its tubes, as you've seen in a previous video, was then loaded up onto the same lorry and taken away for shot blasting, so that that too is clean metal and we can see the wood for the trees and get a professional boiler inspector in to assess it and give us his view. This is the frames in the workshop, and we've started to replace materials. So there was a badly rusted part of angle iron there which we've chopped out, and the same here, replaced with new where and when we've had to, retaining the original when we've been able to. Here, this is the rear buffer beam. You can see it's very badly pitted, and again our approach has been to fill those pits with weld to build up that surface and replace it with new material. The welding isn't brilliant, but it's going to get angle ground off anyway, back to flat metal. That's what Dave's doing here, is angle grinding off my rubbish welds to get it back to a nice smooth finish. The little bits of pitting that we're left with can then be filled with filler or paint and sanded back. We're not looking for a beautifully glass smooth finish here because it's a 100-year-old steam locomotive, but what we don't want is a weakness in the material where it's thinned to a point that it causes structural problems. Here you can see where the cracks have been welded, and from the cracks in the horn guides they've been welded up, sanded back and then filled to make them smooth. You can also see we've got a couple of straight edges clamped to the horn guides. The horn guides have been cleaned up basically so that we could get these straight edges across to give us some sort of datum that we can take measurements from. It's important at this stage to find out what's square and what's not with the frames, with the horn guides and the frames, so that we can decide what we need to machine away and what we need to replace, so that when the axle boxes are ready and the wheel sets come back, we can get them all in the correct orientation and have them square and true. So moving on to a new part of the video now. This is machining a pattern for the valve guide motion bracket, a part that you might remember we looked at earlier on in an earlier video because it was fractured. This is the pattern finished and lacquered, ready to be put in the sand to make new castings. You can see the lugs that stick out either side are for the core print, that part there, and the box on the right hand side is to create the sand core that goes in there, ultimately to create the hole in the casting itself when it comes out from the sand. Here you see the original part that we've got off the left hand side, which we scanned in to digitize the data, from which we made the pattern and then from which was made the casting. The new casting obviously now needs machining, but it's certainly a lovely piece of metal to start with. Moving on now to another new part. You may remember from an earlier video, the top gauge glass fittings are handed. There's a left-hand one and a mirror image on the right hand. Now, we only had the right-hand one. The left-hand one had gone missing at some point. So again, we did exactly the same thing. We took the one that we had, the right-hand one, and we placed little dots on it and digitally scanned it in, from which a computer-generated model was created. We then flipped that model through the horizontal plane to create a left-handed version of exactly the part, and then the pattern was machined in the same way that you saw earlier on the CNC machine, as well as a core pattern to create the holes down the centre of that piece. And then a casting was made of it, which is here shown on the left-hand side. This is the two of them, the original and the new casting on the left. The new one needs to be machined up, but certainly, again, it's exactly right. It's made from a scan of the original part, and it's a part that we were unlikely to be able to source an original part of from any other place. We have, however, been lucky enough to source many original parts so far, and we're still on the lookout for as many as we can find to get the locomotive as accurate as possible. These are original Durance gauge glass fittings as fitted to our locomotive on those job sheets that you saw at the beginning. They're contemporary. They've come off a 1920s Fowler from a friend of ours and a customer, Stephen, and we're very grateful for him letting us have them. Another part that we've managed to source for the locomotive here is a Detroit lubricator. It's actually a little bit more of a modern version than would have been originally fitted to our locomotive, and it's sort of the next size up, so it holds more oil, which in this case I think is probably a useful compromise for us to make. You can see Dave cleaning it up with a wire brush, and it's coming up really nicely. All of the actual mechanical parts have obviously been stripped down at this stage and will be repaired or replaced as necessary. This is Dave cleaning up the open and shut label that goes on the main valve, and that part should clean up, as you'll see over the next few seconds in the video, nicely. But other parts, like the rubber seals that go around the glass windows, will be all perished and brittle, so we'll have to either make new seals ourselves, machining the plastic or the rubber to make them, or we'll source them. We've certainly found some new glasses that we can put in there, because some of our glass that you can see here has been found to be chipped. And moving on to the last part of today's video, another new bit for the loco. This is a pattern for the cylinder drain cocks. We couldn't find any originals, so we borrowed the pattern from another preservation group, Core Box as well, and we made a bunch of new castings, which we will be machining up in a subsequent video. Thanks again for watching. There will be another instalment soon.